The ACE-RTLE Rollout, an autonomous AI system named ACE-RTLE, is currently writing and verifying the hardware code for Nvidia's upcoming microchips. Instead of relying entirely on human teams to manually validate every logic gate, Nvidia deployed localized AI models to bypass traditional physical simulations and draft chip blueprints on their own. But to understand how this system actually works, you have to look at the specific mechanism inside Physics Nemo. Bypassing the math, traditional hardware design hits a bottleneck during simulation. Calculating heat dissipation and electrical flow across billions of transistors using numerical solvers takes hours per iteration. Physics Nemo replaces those solvers with an AI surrogate model. By training on previous simulation data, the model learns the physical causality of thermal dynamics and predicts the outcome in milliseconds, instead of calculating the math step by step. The risk here is distribution shift. If a routing design pushes a chip into novel thermal territory outside the training data, a surrogate model can confidently output safe operating temperatures for a layout that would actually melt the silicon. That hallucination risk is exactly why the physics engine is heavily tethered to the ACE-RTLE coding system. The code control loop. Generic language models fail at hardware design because register transfer level code requires strict functional correctness and spatial reasoning. You cannot just guess the syntax. Nvidia trained Nematron 3 Ultra specifically to handle hardware architecture, pushing it to the top of the comprehensive Verilog design problems benchmark. ACE-RTLE acts as the control loop. It drafts the code, runs the simulation, isolates its own logic bugs, and rewrites the architecture autonomously. It escalates to human engineers only when it hits a hard structural limit. And the way Nvidia is physically deploying this control loop exposes a major shift in enterprise hardware, where this is headed. The integration of Physics Nemo's surrogate modeling and ACE-RTLE's automated coding points to a permanent fracturing of AI deployment, where elite engineering abandons the cloud. For builders and operators, this means the era of relying on remote API calls for core hardware development is ending. Companies are running Nematron 3 Ultra strictly on isolated, on-premise servers. This setup allows them to feed decades of classified architectural blueprints into the agent without leaking trade secrets to third-party providers. If your workflow involves proprietary verification, you are no longer building thin wrappers around generic models. You have to construct localized AI loops. The competitive advantage is shifting from who has the best cloud access to who has the most secure private hardware. Watch the enterprise adoption metrics for isolated agent runtimes like OpenShell over the next 2 quarters to see exactly how much revenue the public cloud providers lose to private stacks. Subscribe for more.